Come on, turn 'em in. Make sure you put your name on.
I just put my name on it. That's it.
Okay, so I see some problems already. So a directional control valve can have either 2 or 3 ports. I'm sorry, 2 or 3 positions. So that's all we have. We have 2 position valves. We have 3 position valves. That's it. And another problem I see we have with ports, the minimum of a valve, the minimum number of ports a valve will have is 2, and the maximum would be 5. 5. Some of y'all put 6. And that would be on a 3-position valve where we have 2. Of course, we also call those waves. That would have been another good question too. What's another name for ports? We call it waves, right? So we have a minimum of 2, a maximum of 5 on our ports. We have 5. We have 2 exhaust ports. Now, of course, what that does is now the 2 positions don't have to share the exhaust port. And then we have the ability of, we're going to add a valve that's got 2 names here before long. It's called a flow control valve, or some people call it a throttle valve. And what we do with the throttle valve is we can set the speed of the flow. We can't make it greater than your pump or the flow rate of your compressor, but we can also always make it less. So the maximum speed your cylinders or your actuators will ever move depends on the flow rate of the power source. But we can always make it slower. So what we can do is normally in pneumatics, and why we do this in pneumatics, and of course we're going to cover this several times, is another term for throttle is what we call metering. We meter the flow. So the problem we have with pneumatics is that if I put the flow control in the pressure side and leave the exhaust side open, then what happens is the cylinder is really jerky because it has nothing to push it. So what happens is it's got compressed air, and as soon as the cylinder moves, the air uncompresses a little bit, and then it has to do what? Compress back. So what we do on pneumatic valves is we put the throttle in the exhaust. So we throttle the exhaust. So that way, if you got flow control, it's always pushing back against the cylinder, and if you have a back pressure, and that way you can control the flow, and the cylinder is not jerky anymore. Hydraulics makes no difference. So hydraulics don't uncompress. So hydraulics, we don't have any problem which way we meter. And the phrase is, when in doubt, meter out, because meter out works on both of them. If we put the flow control on the input on the pressure side, the pneumatic cylinder would be jerky. Huh? The exhaust is the output, would be what we call it. So we have the power source side. In the power source side, we got 2 things on the power source side. We got the pressure port, and then we've got either the exhaust or the tank port. So if it's liquid, we're going to use a return to tank port, right? You understand? If it's if it's pneumatics and we're using air, we're just going to vent it outside. So we have what we call an exhaust port. So that's the only 2 ports that's going to be on the pressure on the power source side. Where your ports vary,
Pressure port and exhaust port
on the power source side. And what we do is we draw these down at the bottom. So here they're calling it pressure and exhaust. If this was a pneumatic, if this was a hydraulic, they would call it pressure and T for what? For tank. And that's the only basic difference. and then the A and the B at the top would be the same on both technologies. So if you're using letters to identify the ports, then of course the P port would always be P. That's the pressure. And then on the pneumatics, your exhaust port is going to be labeled E, right? You understand? And then on hydraulics, it would be labeled what? P. Well, what we can do with two exhaust ports is we can throttle it differently. So I mean, we could deliberately cause it to retract slower than it extends, or vice versa. We could cause it to extend faster than it does what? Than it retracts. And that's one big advantage of having two exhaust ports. And that's where we would come in and have a 5-port valve. You very, very seldom run into 5-port valves in hydraulics. Because hydraulics, if we need to throttle both sides, then we'll throttle in. Because hydraulics don't care. Because hydraulics doesn't uncompress when the cylinder moves. So usually these 5-port valves will only run into those in pneumatic situations. Are we okay? That makes sense. So how many positions do can a valve have? Minimum of what? 2, maximum of 3. And then how many ways can we have? Minimum of 2 up to a maximum of 5. And then of course this would be a 3-position valve, so we call this the center. What we do with the center. So this would probably be pneumatics. And this would be called a what this would do, we talked about this. This would lock the cylinder or the piston in the position, and it keeps pressure. Right? Does that make sense? So we use a lot. Most of the time when we're not using that, and then we get to these 5-position valves. And what you got to do is you literally got to picture that whole thing doing what? The whole symbol doing what? Shift. And that's what you got to picture. And then once we understand the valve, then we're going to have to be able to position the valve. And this is where we have different ways that we can position them, right? And the two primary ways is manual and automatic. So manual means who's got to position the valve. Some units got to go out there and position. Automatic means something is going to do it automatically. We can either do that through mechanics, which most of ours are going to do. So we're going to shift valves mechanically. So what we're going to do when we do that is we're going to probably, I think one of the valves we do, we actually have a cylinder that extends out and shifts the valve. The cylinder itself shifts the valve, if I remember right. Are we okay? So here's just different centers that they have, and they give you basically the names of them and what they would do. So this center, this guy right here, has no center position. So when we put it this way onto the left, then it's going to, depends on what we hook it up, it's going to cause our actuator to move in one direction. And then when we shift it, it's going to cause it to move in the other direction, right? That makes pretty good sense. This right here, when we're in the center, then all the ports are blocked. So what would happen there is our power source would still remain pressurized because it can't have anything, right? The exhaust port would be blocked, and then the valve, the actuator would stay in its position. And then when I shifted it over to this direction, it would cause it to go in one direction. When I shifted it over here, it would cause it to go to the other. What would this center do? So it blocked the pressure port, which is number 1. And by the way, in hydraulics, they use a lot of letters. In pneumatics, when you get into pneumatic schematics, they're going to use a lot of numbers. In fact, I can't remember ever seeing a pneumatic schematic where the valves were lettered. So we know that pressure port is what? 1. Exhaust port would be 3. So what it does is it goes up and down. So and what that means is all your working ports are going to be even numbers. All your power ports are going to be odd numbers. Does that make sense? So that it would go 1, 2, right, 3, 4, and then the 5 would be another power source port. So all your power ports are going to be what? Odd. All your working ports are going to be even.
Pressure port for 1.
Yeah, the pressure port would always be 1. That's an odd number. And your exhaust would be 3.
No, one is an odd
Yeah, 1's an odd number. Did you know that? 1, 3, 5, 7, 9. Those are odd numbers. 2, 4, 6, 8. Yeah. But power ports, you got to understand power ports. Fluid has got to flow in 2 directions, right? You understand? So if we put it out, we got to do what? Bring it back. So your exhaust port would be considered a power port. Then we're going to talk about the pressure port. The pressure port is always number 1. And then your return ports are going to be 3 and 5, right? If we have a 5-port valve. Same for hydraulics. Huh?
It's always going to be A.
It's going to be 1 if they're numbered. A and B. If you use letters, A and B are your working ports. Your pressure port is P. And your exhaust port is going to be E or T.
So
If you letters, huh?
Hydraulic is going to be
Letters.
Okay. And it's going to be
Numbers.
So you said, the hydraulic, your pressure port is going to be A or B.
No, it's going to be P.
It's going to be B.
A and B are your working ports. The working ports, by the way, the ports that go to the actuator. We call those working ports. Your pressure port's real nice because it's going to be what? It's not going to be given a number. It's going to be called P. Your return port is going to be called E if it's pneumatic. It's going to be called T if it's what? Hydraulic. Because hydraulic, we have to return the liquid back to the tank, right? You understand? But on pneumatics, if we use gas, if we use air or gas, and of course air is the predominant gas. I've never seen a pneumatic system that don't use it, but I know where it would be at in applications where we might use it. If it's an extremely cold environment, a lot of times they'll use a fixed gas. They'll use a pressurized gas. And in that way, you have to have a closed system. So if I'm using like nitrogen for my gas, then I don't vent that back in the air. I'd have to return that back to the tank, right? Does that make sense? But in this class, all we're going to talk about is air as a gas. So that's probably used in 99% of pneumatic systems. It's just like airplane tires. Airplane tires, it depends on how high the plane flies. If it flies above 10,000 feet, which is considered to be where the air gets unbreathable, we don't have enough pressure, then they put nitrogen in the tires. And why?
Lighter.
Not lighter. That's a good point. It's not lighter. It don't expand. Almost in. So what happens is we go up and we lose pressure, and according to this law of that, as pressure goes down, volume goes up. That's one of our laws. I should know that. It's all topic. But what happens if we use air? Then what? And we go up above a certain altitude, the tires will blow up. Why I bring that up? Because we had that one time. One of our planes landed in a place where they didn't have nitrogen, so they had to put air in the tires. So when they flew back, they had to fly back below 10,000 feet. Our planes usually do around 35,000 feet. And they couldn't fly. They had to stay down below 10,000 feet, or the tires would blow up. And they wrote up a gripe said replaced air in tires. You put replace air in tires. It's that kind of thing. So what would happen with this center right here? So we're going to block the pressure port. We're going to let it exhaust, but now our working ports are connected directly to the exhaust. So what does that mean? Huh? Well, there's nothing to cause them. The working ports don't move, right? You understand? The ports are stationary. What moves is the spool or the whatever moves. So what could we do? What could we do with this? Well, what could we do with this actuator? I could just grab the thing and I can move it any way I wanted to, right? You understand that? Because when I move it this way, it's going to put pressure on one side of our piston and it's going to go directly to exhaust, right? If I move it this way, it's going to go directly to exhaust. So there's really no pressure there to hold the cylinder in position. Some people call this a floating center, because it little allows your actuator to do what? To float. You can move. That's what this one right here. Go ahead.
So that what we're talking about. Number one would be the pressure port.
Yes. Yeah, when we put numbers, number one is always the pressure port.
So number three would be exhaust.
Exhaust, because it's an odd number, right? So what we do is we start with one, which is the pressure port, and then we go up to what? Go straight up. I'm sorry. We go, and it goes over at an angle, so it goes 1, and it goes 2, and then it goes 3, and then it goes 4, and then it would go 5. So let's look at this. So 1 is in the center, and then it goes 2, and it does what? 3, 4, 5. Can you see the way it's numbered? It's numbered in a what? In an X pattern. And why they come up and did it that way, don't ask Riggs, I have no idea. This is just the way they do it. So the pressure port 1, and then we go up to the right, and that would be 2. Then we come over, right? 2, I'm sorry, then we come straight down, that's 3. Then we go over, and then we come straight down. And that's the way these are numbered. Working port. Y'all understand what that term means? So what's the working port? These are the ones that are actually connected to the actuators, right? Does that make sense? Is that okay? But that just working ports power ports are odd numbers. One. Right. So we okay?
Get that.
Yeah. So we have all different types of centers that would have a different type of application, right? And then this is where we were at. So these are symbols for what we call in pneumatics, we call this a service unit. So these are the different things that's inside the diamond shape. So normally what we do, and these could all be separate, but what we find out normally, if we do the same arrangement over and over and over again, this is also true in circuit. If I have the same circuit, if I use the same electrical circuit over and over and over again, sooner or later, electronic circuit, somebody's going to make it on a single piece of wafer. So the first computer that I worked on, the central processing unit was all made out of small little integrated circuits, and there must have been 500 circuits on that thing to make up the microprocessor or the processor. But when computers became so popular, what did they do? Well, they started, we call it integrating all the circuitry on one piece of silicon, and these became known as integrated circuits. So in the old days, if you took a radio apart, you'd see tons of transistors and all that inside the radio. Now you take a radio apart, you see one main integrated circuit down there, because how long has car radio been around? forever. So to reduce production costs, what they do is they integrate it into one thing. Now it's more expensive for us because used to I could go out and buy a transistor for 15 cents. Now I can't do that anymore because I'd have to replace the whole I have to buy the whole IC. So, but for me putting it together, it's going to save me a ton of money putting it together, right? Because now I'm buying one. I might be buying this guy for $30, but before, when I was doing it with all these other devices, it might have been costing me $100. But instead of costing me 15 cents now. So what they're doing, the pneumatics, certainly we just for a long time in pneumatics we've had a filter because you don't want that any dirt in your air to get into your actuators, right? Because they're causing wear. So we've had filters. We've had some way to remove the moisture if it gets into the air, because that's the problem we have with air in the moisture, right? You understand? So anytime the air heats up and then it cools down, it's going to condense if there's any moisture in there. So we've got some way to remove the water. We've had some way to remove the particles. We've had some way to adjust the pressure. So we have what we call a pressure regulator. Because what we do on these cycling compressors, and we talked about that the other day, is they cycle. So most standard compressors like you have in the home, is they'll compress up to 100 psi, and then they'll drop down to what? Probably at 70. 70's about right. But your air tools are designed around 60. Well, if you ran them, if you didn't have a pressure regulator on there, and you couldn't set it to 60, then what would your air tool see? Well, it would see something between 70 and 100 psi all the time. And what would happen?
Well,
It'd wear out or blow the seals out of your motors, right? So a lot of the compressors that we'll use are cycling compressors. So we have a pressure regulator that we can put in there, and then we've got then we might have an oiler. They call it a lubricator. And then we might have different units. So you can buy these service units with different applications depending on what you want. Well, what we do is we represent everything with a single symbol. And so, and then later on, what we're going to do is we understand that there is a power source available, right? And we understand there's an exhaust port somewhere. So over time, what they've done, and I don't know if they show it here, but let me bring up our first lab that we're going to try to work on today, is they replace the whole power unit with a symbol. So on hydraulics, what we would do is we would come in and so this is the one we looked at the other day. So this is the pneumatic diagram right here. Nope, that actually shows the service unit. So this is the service unit right here. But normally what we'll start doing eventually is we'll use this symbol right here. Can y'all see this? All that is a watt. This is the triangle, right? But can y'all see that? I need to make it a little bigger. Huh? Can we see that? So what do you think that thing right there represents? That represents the pressure source. If it was a hydraulic, so we don't draw the symbol for the compressor anymore, even though we know there's a compressor out there. Now eventually what we'll do is we'll use that to represent everything before it. So when we come up here and look at the diagrams that we're going to be wiring up, or typing, that's the wrong term, by the way. We still call them schematics, which is pretty neat. So that term you learn in electronics or electrical, we're going to use that same term. We still call them circuits. But in this one, we're not going to say electricity or electronic. We learned that a circuit is a complete path for current flow. Here we're going to say a circuit is a complete path for fluid flow, right? That makes sense. So when I come up here and look at our first lab, so notice at the bottom, what do we show? We show nothing but a what? A triangle that's not filled in. Now, if this was filled in, that would be hydraulic power source. If it's not filled in, it's pneumatic. Now, what this is going to represent, everything, how does the pneumatic power get here? Well, it comes from a compressor. I don't know where it's at in this building. I think it's downstairs. And it's also representing the service unit. So we're going to have a service unit. That's the first thing we're going to run into when we come off our disconnect. Is we're going to run into the service unit. And that service unit has a filter on it. It has a pressure gauge on it, and it's got a disconnect on it. So we have the ability to turn the air off at the service unit, which is pretty popular. So okay. So here's our first lab. So so we're going to come in, and what's this assemble for? No, the whole thing.
Oh.
Single acting cylinder. Single acting, right, which means what? Only moves, we use pressure to move it in one direction, and we use something else to bring it back. So this would be a spring return. So what we use is we're going to use pressure to extend it. We're going to return with a spring, right? Huh? Cylinder could be hydraulic or it could be pneumatic. We have single acting cylinders in hydraulics, and we have single acting cylinders in pneumatic. Of course, this is going to be a pneumatic cylinder because that's our labs are only going to be pneumatic. But we have what you're going to find out is hydraulics. Fluid power is fluid power. So just about every symbol we have in pneumatics, we're going to have it in hydraulics. We have so how many positions can a hydraulic valve have? Positions. 2 to 3. How many ports can they have? 2 to 5, right? You understand? Or how many ways can they have? How can they be actuated, manually or automatically? The symbols for the valves are exactly the same. Of course, you can't use a pneumatic valve in a hydraulic system. Well, might work for a little while. But the problem is we got so much pressure, and usually the mechanics and the levers and stuff don't give us the ability to move that amount of pressure around. But in hydraulics, all your seals are going to be metal. Normally are metal seals, like the rings on the pistons of a car. In hydraulics, most of your seals are rubber seals.
Well, last night, the hydraulics were rubber. And the garbage truck compactor thing, got like cross movers that come out, push the compactor part out. We're working on the garbage truck like 11 o'clock last night. So it was fun. But I wasn't supposed to touch the lead on my electrode to the cylinder. And I knew that. I accidentally did that, and it was okay, but it messed it up. And it was tack on. But if I had a tack on it, it would have destroyed that rubber gasket and the golf would have everywhere. Those things are $5,000 a piece.
Right. You probably have somebody else probably has.
Oh, I was so scared because he told me I was putting new rails in or slide back and forth, and he was like, "Yeah, don't touch the cylinder with the electric." And I'm getting up, and my stick sticks out, and I'm like this, touched it for a second, scared the crap out of me. Like, Sean, I told you what you told me not to. So luckily,
So let's look at this valve and see what it is. So how many positions? 2. How's it operated? No, that's return. It's manually operated spring return. So the spring is not, when we talk about the operator, normally the operator is how the valve is shifted, right? So we can manually shift it both ways, or we can automatically shift it both ways, or we can automatically shift it one way, and then the spring would do what? So normally when we say how the valve is operated, we would start off with how do we shift it originally. So we would say what? So this is manually operated spring return. That's the way we start off. So what we do is we start off with how so the spring is going to do it automatically, right? And the other one's going to be manual. So that's a symbol of a manual operated valve. What's that? So what we're going to have to do, of course, is we're going to have to learn these operators, because that's manual operator. And of course, this says, okay, this is a manual operator. This is generically manual operated. Huh? I don't know what you mean. This? Yeah, this is the manual. That's the symbol for manual. How do I know it's manual? Because that's the symbol for that. Okay. So it's just like everything else. We're going to have to learn symbols, because in schematics or for these diagrams, they're not going to draw the valve, and they're not going to draw the lever, they're not going to draw the spring. What are they going to draw? They're going to draw a symbol that represents how the things operate. What do you mean key? Yeah, of course we're going to do it, but what you need to do is just try. You'll have to memorize them. And that's what we're going to look at. This is the PowerPoint, by the way, just about all the operators. And let's see if it's in the book. So let's look at valves and see if it's in the book. I don't have my book up here. I know it's in the PowerPoint.
Yeah, it's on 28.
Yeah, so 28.
Looking for the symbol
For the operators.
Yeah.
And these are what we call the generic. There's a lot more than these guys, but these will be all of them that we're going to be using in this class. So most of our valves in this class are manually operated. By the way, let me tell you what we're doing in this class is that when I got here, there was only one person here,
at 9.
and they came in and went back out.
Really?
Hey, this is my last week. I work the street work now.
We're going to have to do something about that. So what we're going to do in this class, and we did that this morning. If you missed it, I'm sorry. We're going to have to start. What I'm going to start doing is giving a little quiz at the start of class. And if you're not here, there's no makeup on that. So this is one method that we can use if we have problems with class people getting here on time. So it's imperative that you get to class on time. So right now, if I was in business, there was a line out at U.S. Steel. It was number 4 galvanizer line that cost the company about $12,000 a minute. And that line was down.
What kind of line was it?
It was the galvanizer line. It's where they actually put the tin plating on the strip metal.
$12,000
A minute.
a minute.
A minute.
Did I just get
So what would have happened this morning if all my crew didn't show up to run the line? I would have been another crew, right? Because y'all would cost me a lot of money, real fast. So, if I'm depending on my labor force to get there, and then plus, guys, a lot of people want to use me as a reference, and when you're using me as a reference, you're not using the college as a reference, you're using me. And I don't lie. And you know the questions they ask me most often? No, the 2 questions I get asked almost every time is, how well do they work with others? and do they show up on time? You know? And I'd say, man, he works great, but he's never on time.
Yeah, that's me. Fortunately, I know that's me.
Well, so this triangle right here, this is a symbol we're going to use to represent everything before that, right? You understand that? So what's going to be before us? Well, what before that is going to be the service unit. Everybody okay on the service unit now, what that does? And then the compressor somewhere. Like I said, I don't even know where it's at in this building. Nancy bought a big compressor. It's over in that, and we don't even use it anymore because we're running on shop air. So
How much was the compressor? What kind is it?
I don't have the slightest idea. I think it's a Craftsman. I think.
I have that.
Yeah, that's what I have too. Mine's
Is it 2 horsepower?
I've got the data sheet in here on compressors. I'd have to go back and look. But that's something. It does a job I need to do. But I don't know that right off the top of my head. So these are the operators that's covered in the book. So ours are going to basically be manual operated. Some of them have what we call detents. And what do we mean by detents? Is that it's going to have a knob on it, and when you put it in a position, it's going to stay there. But it's not being held there by a spring. It's being held by what we call a detent, and you can actually feel it when you snap it into place. Blackboard, I think, called them actuators, but that's not exactly true. These are operators. And we got a big problem with our pneumatics lab guys. I need to find Nancy and see if she's got an inventory of what's supposed to be in each trainer. Yes, but we're going to have to kind of, everything's over there, but the problem is, what's happened is that people have been moving stuff around. So there's some trainers over there that has almost nothing in them. There's some that are packed as full as they can possibly do. So what the instructor had been doing is so what we should do, and I'll try to find out Nancy's inventory the trainer when we get here, and then inventory it when we leave. Because there's some of the circuits, and I can understand why. There's some of the circuits that, like especially at the last lab that we did, where we're going to let you have to design your own circuit. They want more double acting cylinders, and they borrow one from another trainer, which is fine, just as long as we do what. As long as we put it back. So it's fine, but what happens is now it's going to be mass confusion in the lab because you need a valve and you don't have one in your kit, and now you're going through the whole thing. Y'all heard me over there going through drawers over there trying to find where they're at. So y'all be doing more roaming around than trying to get the lab together. So operators. So the first lab we're going to do. This is a hand operator or lever operator. This is cam operated. We got one of those. We don't have any solenoid operated valves in this lab. All ours are going to be mechanically operated. We say don't show up here. They're either going to be mechanically operated or manually operated. So one of the first valves we're going to use is this guy right here. And normally what's nice is what they do is they'll put the symbol let me get back over to my camera here a second. So they put the symbol on the valve. So here's our first valve right here. By the way, this guy here uses DIN rails. I'll show you how that works. It's really, really neat. And what it does is it makes for easy maintenance on your different valves. So what we got is we got a rail that's got a split in it, and all we do is we insert this key into it, and then we can press on this, and y'all can see it raise right here. See it raise, and then you put it in the rail, in the DIN rail, and you let it go, and it latches in. When we look at our when we look at our cylinders, what we see is we have these two guys right here. And then what we do is make sure they're lined up, and then they slide into the DIN rail. And then what we do is you turn these and lock them down. So you can see what happens when I turn them. What it does is it starts spinning, and then it's got a screw on there, and then it just tightens it into the DIN rail, because we don't want these to move real easy, right? Because these are our cylinders. So that's all you have to do is just line them up. And if you unscrew them too far, what's going to happen is the little latching mechanisms are going to fall off. Don't try to, don't turn them too far. So this is our first valve that I just knocked out. And this is our first lab, so I'm going to turn it over, and you see what they do is they actually put the symbol on there, if I can get my camera to focus. So how many positions? 2. Manually operated spring return. And here's our manual operator right here. It's this green button. So that's what you're doing when you press that. This is going to shift the spool inside the valve. Oops. I got to turn this camera off before it lets me go back to my PowerPoint.
Are these slides on the course content?
Yes. These slides?
Yeah.
Some are a little different, and like I said, I didn't taught this class, and there's a little problem with some of those. Yes, I will. Yep. Thank you, Austin. Alfonso, I'll get y'all back on the road, because right now I got Mark Watt. Absent.
This still want me out yesterday. All right.
Yeah, I need to go back and change that. I know you came in. Luckily, we can do that now. Yeah, before we went to the new version, once you submitted attendance, if we had to call computer services and have them open it back up so we could count it. But now we can do that, thank goodness. This is a valve that we're going to use in our second lab. And this is, so I don't know, let me try to get this in front of my camera. Can y'all see this? And let me move it back a little bit. It's hard to see. I can't zoom in, I don't think, with this camera application. I can make it full screen. Maybe that'll make it a little bigger. Okay, it does. This is 2-position spring operated, but I don't know if you can't really see this, but inside the operator there's these little tiny notches, and it's got 2 of them. Now what that means is that means we have a detent. And of course this camera won't switch. It won't switch while that camera's full screen. So that would be this symbol right here, this detent. So what we see on this one is I have a selector switch on the front of it. And then when I turn it, it stays in that position. So that's what the detent does, right? It keeps it in that position. And it's spring return, so as soon as I move it out of the detent just a little bit, it should flop back over into the position. But as long as I leave it right there, it's going to stay there forever, right? And that's what the detent does. It does what? It holds it into a position. This is our single acting cylinder. This is what we call a round cylinder. So the problem with these round cylinders is they're basically non-repairable. They're cheaper, but they're non-repairable. we have another cylinder that they call an MFPA cylinder, which basically, I'll show you some pictures of that, but it is a repairable cylinder. So I mean, there's nothing on that thing, you can't change that. This guy right here is a round cylinder, and this is non-repairable. So if a seal goes out on this one, what would you do? Yeah, you'd throw it away because it's sealed up. But this is the pressure port right here. Now what we do, what's nice about the pneumatics is that we have these things called quick disconnects. We could screw it in, but on all ours we have what we call quick disconnect. So this is a quick disconnect. And I didn't bring any tubing over here, guys. But what we do is when you push the tube in, so when you push the tube in, you push down on this, on the quick disconnect, then you push the tube in as far as it'll go, and then when you let it go, it'll latch it in. And then when you put pressure on it, it actually latches in real hard. So it's extremely hard to pull out if the pressure falls. You can, but you're going to have to get some type of, usually need those pliers or something where you can really put some pressure and hold that down. If you don't push in there far enough, guess what's going to happen? It's going to blow that tube out. So this is one reason we wear safety glasses, because this happens every once in a while.
Pressure board.
Right.
So these little lines that go through the filter, like those are always looking for.
No, the lines are showing you the direction of the fluid flow.
Okay, I was wondering.
So the arrows are showing you the direction of the fluid flow. So you notice one of them points toward the working point, the other one points toward the exhaust port. And then when you move the valve, you notice they crisscross. And why do they crisscross? Because what you're going to do is you're going to let it do what? Extend and retract. Now this is a, in fact, guys, it might be better if I use my, so this is the exhaust. So here we got one port, okay, and then we got this little old tiny hole right here. This is the exhaust. This is the exhaust for the cylinder. So this, we don't have to exhaust it through the valve. We can actually exhaust it through the cylinder. So using this valve wouldn't be necessary. All we need to do is have a two position, right one thing, and then just switch it over. We don't have to have a crisscross. That makes sense? And of course, this is spring return. So this is the exhaust port. So if you block it with your thumb, right? Of course, it's going to move a little bit because it's a jam. This is our single acting cylinder, and I didn't bring a double acting cylinder. Along with a double acting cylinder valve, it would have two of the quick disconnect. All the service units are bolted down over there, and it takes an Allen wrench to get them off. So we'll just have to see those when we go over there. We do have this unit right here. We call this a manifold. And what you do is the big tube right here, I'm sorry, wrong side of this. The big tube is where your main pressure port would come off of. By the way, these quick disconnects on these, the way these works, if you don't have a tube in them, then they block the air. So what we can do with this manifold is we can have one pressure coming in, and then we can output this many pressures to different devices out in our system. Are we okay there? Of course, this is a pressure gauge. Right? Unfortunately, we don't have any flow meters, so we teach how to calculate the speed of a cylinder, but we don't have the ability to do it here because one of the main things that you're dealing with is the amount of flow you have. So you can't calculate, or at least I hadn't found one of them yet. We can't calculate the speed of a cylinder until we know the what? Flow in the area. This right here is this would be one that's mechanically operated. So what happens is when something comes over here and pushes on this, this is actually, this operator right here, this actually shifts the spool in there. So that would be this symbol. I'll get to it in a minute. Where's my PowerPoint? That would be this symbol right here. So it would be a cam operated valve. So this would move us more toward automation, right? Because now what's going to happen is something's going to come up here and hit the operator. And then that is going to change the position of the turn it. This is a pilot operated valve. We'd have to figure out. By the way, these guys right here are technically referred to as silencers, but just about everybody calls them mufflers. And that's these guys right here. Now it works a lot like the muffler of a car. What it does is it breaks up the paths that the fluid that the air will flow out of. So if the air flows out of different paths, then the combination of the exhaust does not pop, right? You understand that? So these little brass things, these are called silencers. And you should see them on your valve. Usually on the side of your valve, on the exhaust on the valve should have a silencer on there. But mufflers, you don't understand mufflers, right? This is a pilot operated valve, and we'd have to look at it and see how it works. So it's got another port on here. This is port 14. So it's an even number. So what does that mean? No, that's right. It's an even number. So, but it's not. We'll have to talk about this, I guess. But it's got 12 and 14 on here, and this is a pilot operated valve. So what's a pilot operated valve? Nobody remembers? So what's a pilot operated valve? So this is the symbol that we would use. And that one's not quite the right symbol. But this is the symbol that we use right here. This would be hydraulic, by the way, because it's what? Colored in. Ours, we're going to have a triangle that's not colored in. And this is pilot, what we call a pilot operated valve. Everybody remember what we said a pilot operated valve? Nobody remember? So what's a pilot operated valve? It's operated by fluid pressure. So what we'll do is we'll have another valve that changes the direction into that into the pilot port on that valve, and that's what causes the fluid. Huh? Anything that's electromechanical devices on that. Some of them are repairable, some of them are not. Some of you have to replace the whole, like round cylinder. These guys are considered non-repairable because the end caps are solid on there. The rod cap and the end cap is solid on there. And we do have what they call a naphtha cylinder, which basically has what they call power rods. I'll show you a picture. But it's basically got 4 bolts on each side that run the extension of the cylinder, and you loosen them up and you just break off the end caps, the rod cap and the end cap, and you can pull the cylinder out and loosen them out and replace the whole thing. So the advantage of those, they would be more expensive, but they would be what? Repairable. These guys are less expensive, but they're unrepairable.
My question,
Huh?
these are software, high degree of software.
Right, those are
Silencers.
mufflers. Silencers is a technical name. So if you looked it up, or we're gonna order them, odds are you're not gonna find them as mufflers, you're gonna find them as what? Silencers. But just about everybody calls them what? Mufflers. And we'd have to figure out what's going on with the pressure, with the pilot ports. What else? So these are some more operators. This is not in your book, but we're going to run into these a lot. First of all, this guy right here, and I wanted to show y'all this. So I'll bring my camera back up. I think this will work okay. So when we place electrical current through a wire, what it does is it creates a magnetic field. So we have permanent magnets and we have things we call electromagnets. So electromagnets create a magnetic field through electrical current flow. And so all I've got here is just a screw to concentrate the magnetic field. And then I've got a bunch of wire. This is called magnetic wire because for the magnetic fields to combine, you can't have hardly any insulation on the wire at all. Which means now we got to be real careful with this because this stuff right here will scratch off. So a lot of times this will all be encapsulated inside a big nice chunk of plastic, so you can't scratch off the covers on the wire and then you create shorts. But this is just homemade, so this is magnetic wire. I'll pass this around. So the insulation is really, really thin. In fact, to strip this, you just get a blade and just scratch it off. What I'm going to do is I'm going to come over here. I'm going to take this and I'm going to put a DC current on it. So this would be a DC valve. And then what I'm going to do is I'm going to take this nail, which is a piece of metal, and then I'm going to put it down here on the table and I'm going to turn on my power supply. I'm going to turn off my power supply. Turn on my power supply. Turn off my power supply. So one of the big advantages of an electromagnet is we can do what? We can turn it off and we can turn it on. And y'all have all seen these where they movies and stuff. You actually sit where these scrap cranes are going around swinging stuff up and dropping that big old puck down in there. What is that? That's an electromagnet, right? You understand that? Then they turn the magnet on, they swing it up, got all that scrap metal down there, they swing it over somewhere else and do what? Turn it off. And that's one of the big advantages. Another thing we can do with this is, notice on this one, this is homemade too, is I've got all the magnetic wire wrapped around a straw. So what I've done is I've come up here and created a hole for this. Now what I'm going to do is I'm going to take my magnet, I'm going to take my power source and put it across this. And what I'm going to do now with my nail is I'm going to take my nail and I'm going to put it in the center. And now I'm going to come over here, where am I at? So this is what I got. So I'm going to come over and put it in the center. Now I'm going to turn my magnet on. I'm going to turn it off. Turn it on. I'm going to turn it off. So you can't see this, but on the top, when it pulls it on the bottom, it extends it on the top. This is a device we call a solenoid. Oops. Undoubtedly, I don't have a good search. So this is a device we call a solenoid. So we use solenoids for a lot of things, and we use them for valves. So your washing machine, turn the water on and turn the water off. What do you think it probably uses? Solenoid. And what it does is it takes that rod, when you turn it off, it jams it down there, blocks the water. When it wants to turn on hot water, it runs it up. Everybody's been into these doors where they have to buzz you in. Well, what locks and unlocks it over? That's solenoid, right? You understand? Well, since it creates this motion, what can we use that for? We can use that to shift that spool, right? So what we have, and what's nice about these is these are electrically operated, and I can control electricity, precisely. We don't have any solenoid operated valves, but this would be the symbol right here. Oops. So what we do is we just take a rectangle and put a slash line through it, and that means it's what? It's a solenoid operated valve. And these are some solenoid operated valves. These are hydraulic valves, by the way. You can actually see the ports on the bottom, which is pretty good. Can't see the spool, so these are the solenoid connections on each side. Now, most solenoid valves, we'll show you the symbol, has a manual override. So we have the ability to take something and push it in on this little brass end on the end, and it gives us the ability to shift the spool manually. So that way we can shift it electrically, or if something happens, we can do what? We can shift it manually. So these are hydraulic valves, and you can see the difference in size. But these are all solenoid operated. Are we okay? That makes sense? So now we can do it automatically. So now my programmable logic controller can shift the stuff. And I control the PLC with it's called programmable, which means I can do what? I can program it. So I can determine when it shifts. So all the pneumatic valves, except for the disconnect, over on the two lines that we went over and saw, those are solenoid controlled valves. Now the problem is, so that would be this guy, and the problem is they don't show the other symbol. A lot of times the solenoid cannot create enough pressure to shift the spool because it's going to be working against a fairly small surface, right? You understand? And the amount of force we generate, what's the formula for force? Yeah. So what happens is my solenoid is not going to have a lot of area out there on the end. So force is equal to area times pressure. So what we need to do is your solenoid can't generate a lot of pressure, right? You understand? So it would take a rig bill area. Well, we don't need to have a lot of real big area to work with. So what we have, though, guys, is we have a pressure source available. So what we do is we'll come over here and we'll have a solenoid that opens up a little valve. And I'm going to show you a video. And then this is going to let the air pressure come through. And then the air pressure or the hydraulic pressure shifts the spool. Right? You understand? So, you know, our system we're running, I think, at 60 psi. Hydraulic system might run at 1,000 psi. So we can just do a little old tiny hole because all we're going to do is change the flow a little bit, but the pressure and flow are two different things, right? You understand? So I could use my little solenoid to open up a little port. That port could come up and apply a lot of pressure and do what? Shift the spool. So these guys right here, solenoid. Oh, where's my PowerPoint at? I keep going. I'm sorry, guys. Slow down, Rich. So this is this symbol right here. So if you see this symbol right down here on the bottom, you see the one I'm talking about? So what it's doing is combining two symbols. So this is the symbol of a solenoid. This is a symbol for a solenoid pressure assist. So this is what a pilot. So it says all this is going to open up a pilot valve, and then the pressure is actually going to shift the spool. That makes sense? So just about all the valves over on our line over there, and I've got one, by the way, that I can hopefully bring over here. We've got one where the solenoids have burned up on them. We leave our robots on 24 hours a day, and what's happening with these two-position valves is that normally to keep it in one position, you have to keep water on there all the time. You have to keep pressure. And so the solenoids are staying on 24 hours a day, and they should be able to handle that. but undoubtedly, when they put those valves in there, they didn't choose one that would run forever. So we got one of our robots over there now and it controls the what we call a gripper, and we can't use it because it's the panic over there if you're in operation and programming. We can't use it now because we can't open and close the gripper because the valve is locked, the solenoid is locked. They're not stuck; they're burned up. And they are solenoid activated pilot. They're pilot seals. So I think it's basically all our operators, except that the book don't cover this one. This would be a foot pedal operated valve, right? This would be a manual push button. This is just a manual control general. So when I come over here and look at the, let's see if I still got it going. Yes, I did. So when I look at this valve, what does this valve tell me? This valve right here would be what? Solenoid operated, spring return, and then we got this little manual operated thing over there. What would that be? That would be the manual override. So that would be that button that you can stick something into and override. Yeah. Now notice it's real short. So all these are. So this would be. This is single solenoid operated spring return with a manual override. Now this is double solenoid operated with a what? Manual override. Yeah. See that? So this valve over there, but all these, notice the valve in here is the same. And what's really neat is that the valve don't care what shifts the spool. So a lot of times the valve assembly itself will be the same, and what you clamp onto the side depends on how the valve's operated. So these companies don't make a manually operated valve. They make a valve, and then we tap the what? We attach to the sides how we want to operate the thing, which is pretty neat. So I'll try to get those off the FANUC and bring it over here. And you can see the little pilot port. We'll see the solenoid. We'll see the pilot port. We'll take the valve apart. We'll see the solenoid. We'll take the pilot port. So these valves are repairable. Anything else? I guess that's it. Let me go back to I've got a video I want to show you guys too. So basically, if I can find it. Let's see if we turn on.
In most air and hydraulic fluid power circuits, valves are used to control the direction, rate, and pressure in fluid lines. Control valves for these functions can be purchased with either manual or solenoid actuators. In a manually actuated valve, the internal cylinder is shifted by hand using a lever, push button, plunger, or other manual actuating device. By contrast, valves with a solenoid actuator respond to an electrical signal for shifting. With electrical control, machine cycles can be set up for automatic sequencing, and operator control can be exercised from a remote location. Solenoid valves are said to be either direct or pilot operated. A direct operated valve is shown here. A pilot-operated valve has a pilot and bleed orifice and utilizes line pressure for operation. This is a pilot-operated relief valve. When the solenoid is energized, the core opens the pilot orifice and relieves pressure from the piston or diaphragm to the output side of the valve. This results in an unbalanced pressure, lifting the piston or diaphragm off the main orifice. When the solenoid is de-energized, the pilot orifice is closed and full line pressure is applied to the top of the piston or diaphragm, closing the valve. Most directly operated valves also come in pilot-operated versions and are designated by a triangular graphic symbol. A single solenoid valve has one solenoid to assist in valve operation. The valve spool shifts when the solenoid receives an electrical signal and is energized. The valve will remain shifted as long as electrical current is applied to the solenoid. Once the electrical current is removed and the solenoid is de-energized, the valve returns to its normal position by spring force. Fluid circuits designed to use single solenoid valves must maintain electrical current in order to keep the valve in its shifted position. Double solenoid valves have two solenoids, typically mounted on opposite ends of the valve body. This type of two-position double solenoid valve does not have a spring return. When the first solenoid is energized, the valve spool shifts into the first position. Even if the first solenoid is de-energized, the spool remains shifted. This is because there is no spring to return the spool to its original position. Energizing the second solenoid will send the valve to the second position. Even if the second solenoid is de-energized, the valve will remain shifted until the first solenoid is re-energized. Since there is nothing holding the valve in the shifted position other than friction, these types of valves should be mounted horizontally to avoid self-shift due to excessive airflow or vibration. If both solenoids are energized at the same time, the solenoids will work against each other and may cause the spool to become stuck, electrical burnout of the solenoid, or an overload of inrush current to the circuit, any of which will cause severe damage to the system or valve. A three-position valve has a spring-centered neutral position for its internal spool. Because of the centering springs, it's necessary to hold current on one solenoid or the other to keep the spool in one of its side positions. When each solenoid is energized, the valve shifts to the appropriate position. Anytime both solenoids are de-energized, the valve spool will spring to center and stop the fluid flow. Therefore, a three-position valve requires a maintained electrical signal for its operation. As before, energizing both solenoids at once may cause damage to the valve or to the system. To prevent this from occurring, electrical circuits should be designed to make it impossible to have current on both solenoids at the same time. Solenoid valves are used in both hydraulic fluid and air systems to control direction on cylinders from deceleration or speed control and pump unloading or pressure control. The physical appearance of each component will vary greatly depending on brand, size, and type, so care should be taken to reference the appropriate manufacturer's guidance when choosing a solenoid valve.
We'll come up. a circle, and then we'll put either a solid or a triangle on one side. If we do that, this is going to be a pneumatic motor, but it's only going to be able to run in one direction. If we come up here and do this, thinking about it, let me go back and correct the rows. Yes.
I'm gonna try to be here as much as I can on time. I really don't want to have to drop the class.
Well, you don't have to drop the class. The test that we give will probably go into they'll go into the assignment section.
Come on, quiz in the morning.
Yeah.
I know on Mondays I usually be here on time. I thought she was gonna teach the PLC class.
No, we had to cancel that. We only had one person that had paid in that.
Is that the advanced one? Oh, I'm taking the.
No, I don't teach intro. I do every once in a while. I teach intro to PLC. It's been a long, long time.
I want to know everything I can know about PLCs. I'll take the exam too.
Yeah, and I need to talk to Brittany and make sure that she tells the students that we're teaching in the spring.
Oh, you are? Yeah, I'll
I'm not, yeah, we're teaching spring. And it's a day class too. How do I know that? Because I'm teaching it, and this is the first time in I don't know how many years where I'm not doing any night classes. I don't do any night classes this spring.
I wish you had about that.
Don't know.
You don't know?
I'm so used to teaching night classes that don't really bother me. And I don't do 4 nights a week, so 2 nights a week. So I end up working about 10, 11 hours on those days, but then I get off Friday at 12 o'clock. So a full day schedule that means that I'll be here until 4 o'clock on Friday. So I like getting off at 12. So I don't mind night classes. I usually have a pretty good break too. So I get off at 1 and I come back at 5. So I have 4 hours between the classes. It's just you can't do anything between that time really, but that's the only big deal. I only do 2 nights a week and then I get off at 12 on Friday. So.
And you only do 2 classes because you only choose to do 2 classes?
What do you mean?
Could you do more? Could you teach more in a week? Or is that all?
No, I don't. I only do 2 classes at night. I only do 1 class at night. I'll teach 2 nights a week. We don't do any. There's only a few classes that we do on Friday. Just about all our classes we do Monday through Thursday.
What class do you have on Friday?
Hoyt does some of his classes. Hoyt's got a residential wiring course. That's a 6 credit hour course, and it's supposed to meet 9 hours a week over 16 weeks. We can't do that as a mini term. So 9 hours a week over 16 weeks. That means if he tried to do that 9 hours a week, if he tried to do that in a mini term, he'd have to do 18 hours a week.
Yeah.
2 days of class, two
Or
days.
just break it up into 2 different classes or something, kinda like how they do PLC, how you got your first one and then.
Well, no, it's residential wiring. It's really, well, the problem is that when we choose courses, we have to choose them from a state-approved list of classes. And what that does is that means anybody that takes residential wiring at Lawson State can go to any two-year college in the state that teaches residential wiring. And they teach the same material, they have the same contact hours, same credit hours, same lab hours, so they transfer, they don't even think about it, they just transfer right in. Used to, everybody, when I first got in the system, we made up courses. So there was no, so we taught courses. So we'd have a bunch of students that would say, heck, I want another course in electronics. We'll say, okay, we'll put one together. We'll throw it on there, and once they got so many credit hours, they would graduate. But that created a big problem over the state. So that's why they created a course directory. So we have no option. If we teach residential wiring, it's got to be 6 hours. I mean, it's 6 credit hours because the labs in there take a long time.
I'll bet.
So he can't do it in a mini term, and it still would be 9 hours a week. So he does it 3 days a week. So what that'd be 2 hours?
3 hours a day.
Yeah, 3 hours a day, which is not bad.
No.
And so we don't, and we do some 5 credit hour courses that need that's seven contact hours, and we don't do those in any term. But we solid state and digital, those are 2 5 credit hour courses. So those are the only courses that we teach full term. It's solid state, digital, and residential wiring. Now the problem is when he teaches DC after residential wiring, the class would have to meet from like 3 o'clock to 6 o'clock. So he does that 3 days a week when he teaches it.
So he's teaching all the time.
Well, we all teach all the time. So we have to teach, to be full time, we have to teach between 15 and 17 credit hours every semester. So if I teach mini term classes, that means one semester I would have to teach 3 classes, but then I wouldn't have any office hours because that would be 25 hours a week. I'm sorry, that would be 30 hours a week. And we're only supposed to be on campus 35 hours a week. So we get paid for lunch. But we're supposed to be on campus 35 hours a week. So that leaves me 5 office hours to do everything else.
Yeah.
But the next mini term, we only teach 2 classes. So that would be our 5 classes. And that way, you're doing 20 hours a week, so you have 15 hours a week off. If you do a full term class, you're basically screwed. So I do 27 hours. So I swap classes, but I'm still doing that full term class that needs 7 hours a week. So I'm doing 27 hours, so that gives me 8 hours worth of office hours. Now, an academic instructor, they teach 15 credit hours. They do 15 hours a week. So they have 20, so a math instructor has 20 office hours every week. Is that fair? And we get paid the same. Well, that's not true. You get paid according to your education and your years of service. So the more education you get, the better, the more money you make, and then years service. Up to 30 years, I think. After 30 years, you don't get any years service anymore. So I don't get any years service anymore. What happened to my attendance? So now you know the whole system. Let's see. No Kevin Beaver staff. Alfonso came in. James never came in. Dang it, James. I don't know what I'm gonna do about you. Dantes never came in. Melvin's never been here. Justin came in. In fact, Justin made it in time to do the quiz. Joseph never made in. Courtney made it in. I think I got everybody. I think everybody's here. So Austin came in. Alfonso came in. Courtney came in. And I need to go back to here because Alfonso came in. By the way, Alfonso informed me that the reference books are in the bookstore now.
Yeah,
Little book that y'all be able to use in y'all's in type test. Let me see one. I don't even have one.
I think they, I don't know. I got the receipt right there.
Oh yeah. I need to get you one of these and scan it.
It's $1.50.
So it's got a whole section in fluid power, converting from English to metric. It's got airflow, cubic meters per second, cubic feet per second.
Sold for $10.
So everybody about $10.
Nah.
Vehicle drive calculations, hydraulic cylinder forces. So instead of you trying to do all the calculations, it has different pressures. Of course, the pressure this guy only has is 500. This would probably be more hydraulic. That would be hydraulic. Air cylinder consumption, horsepower, tubing, oil pressure losses in pipe. This is a big book. Next is that you've done. It's how much? $1.50. Now that book, of course, y'all know, and like I said, there is a lot of formulas in this book, in this class, but what we'll do is we'll let y'all use that book on test.
That's a small book.
Yeah, it's in.
They have more.
Yeah, there you go. Alfonso said there what?
$8.50. That's all. That's the yeah, they don't. Almost glad, right? I'm supposed to.
Uh, what they do?
How many you got in the You need another one? I'm looking for time my own way.
I got another one.
They gotta have one every turn. Try my brother. Let's see.
I think he got that one in there he was demonstrating. The one he was demonstrating in there.
Y'all see my stick in here? My hand? There it is. What's the matter? Manifold. Yeah, this has to go around in here somewhere.
The cylinder's supposed to be one spring.
What is the symbol for? Okay, so that's one for P. Shouldn't have to ask you that.
What do you think is it, got spring return?
Oh, I thought, I was saying, the one that he was demonstrating to us earlier, the city project.
Oh.
No, I didn't. Somebody else brought it. Okay, guys, y'all listen up. Everybody listen up. Y'all look in y'all's drawers and see if you find a single acting cylinder in there.
I got one.
You got an extra one?
Not an extra one.
We're looking for an extra one. I'm sorry.
Two.
We looking for anyone that's got two of them in there.
I got one extra.
Okay, so Alfonso's got one extra. I'll do that for the number, right? I don't hear that anymore, right? Alright. We're not working on tape.
He had used, one of my, his manifold ain't working.
Yeah, but that's what they're trying to So what we're doing is just put it this way. Right, so well, no, all together. Then what happens is it's right here. And you shift it over, then this right here is supposed to be dissolved. Shift this over to the here's another single acting cylinder. Who needs one? Who needs a single acting cylinder? Everybody got one?
Yes.
Got one?
Yeah, I'm good. So you got 12.
This is not exaltable, this is a pressure. So we need to add. These right here are they seal up. But you can see how hard I put that in. So what's happening if you don't have it, let me work. I can come up here and pull it out, and I can turn this on. If I come up here and do this. Yes, there's really nothing in this guy here that can go wrong. Because all it is a bunch of tubes there, right? And then these fabrics. Now I can understand why one of these would go wrong, but I couldn't understand why all of them go wrong. So either this wasn't in there good, or this one wasn't in there good. Well, if this wasn't in there good, it was wrong. If this one wasn't in there good, yeah, this is good and all that. So it had to be one. It had to be in here. So these don't seal up, all these are here.
When I'm at the butt, it should push out and then come back on.
Right, shift this back over to the top. If I didn't give rid of the pressure on this side, then we wouldn't have anything to go. So what this valve does is that it shifts this back over to the top, right? So what happens is we shift it over. Okay, so pushes on that side. Then I shift it back. The spring pushes it this way, and then it goes down to the top point on the valve. So I must exhaust on the inside because it shows the port three there. Port three is exhaust, but it won't be inside.
No, when he done here, all he rolls out.
Well, he's gonna roll, what's that? So what does that mean? So let's look at your symbol here. So in the normal position on this one, now this is the normal position, he goes out for two. So on your normal position, okay, in your normal position, okay, you're going out this port right here, right? So what he's done is he swapped these two ports. So you would put this in the bottom, but that one in the bottom, and yours is going like this.
No, that's a different.
They got different valves. Yeah.
This is the difference. Bring out the pressure. Pull these thing out the pressure.
Yeah, 2 feet is good.
Right? So this valve is backwards.
Wait a minute. Now,
Now, if you look at his, what we do is we know that these two things are swapped around. So look at, so you notice, this is the normal position. So here's two goes back over here, two goes back to the top. Yeah, y'all come here a sec. Huh? That's okay, y'all come over a sec. So the question was asked, is, okay, so it says, when this one comes, when we turn this one on, the valve, the cylinder is retracted. When we turn that one on, it extends. Now why? So when we look at the valve, so this is the normal position right here. Well, notice 2 is sent to exhaust. If you look at there in the normal position, 2 is sent to pressure. So the valves are actually different. So some of y'all's, depending on which version of the valve you have, some of them when you turn it on, it's gonna do what? Extend. Some of them it's gonna do what? It's gonna do retraction. So it just depends on the valve. So this guy here, now we can make them operate the same by swapping 1 and 2, but you don't need to do that, right?
Well, we swap 1 and 2. It'll let you release one of the valves. It'll just have continuous flow.
Well, that's right. What we're doing is we're exhausting the full. So what we're doing is we're taking that and sitting over the valve, so we can get it. So, this is the right valve according to the schematic. So what y'all need to do, listen up. If yours comes out extended, what does that mean? That means you're using the wrong valve, right? So notice on this one, it shows the normal position, 2 is supposed to go to exhaust, which would be what this one shows right here. So 2 on the normal position, 2 goes to exhaust. Then so this one has the wrong valve. It shifts over, and then the pressure shifts
there.
You saw the valve. I got one.
So what we're doing, when this thing retracts, the spring is pushing it back. If I didn't do anything with the air, yeah, so if I didn't do anything on the air on this side of the cylinder, it wouldn't do nothing. So what happens is now this will go out and go to the top and allow the spring to push it back. Okay? So let's put that on. What? Well, there's one around. We got two. Yeah.
Am I good?
So y'all need to look for the right valve, y'all okay there? Which one are you working on? Which one are you working on? Which one are you working on? Okay, so you need to find one that's not nobody's using, figure it out, and you compare it. Okay, anything, by the way, anything that's not, y'all listen up, I'm gonna come up with some lab procedures too. I'm not a very smart person, and I come up here and I see 15 modules up there on the trainer, and you're only using 2 of them, that's gonna get me very confused. So all I wanna make sure y'all do, anything that's not part of your current circuit needs to be in the doors, right? You know what I'm saying? And that way, Rich don't get confused. I don't wanna get Rich confused too.
I think I'm good.
So let's see it out. 75 feet.
He is already blue.
Oh, yeah,
To 60?
60, yeah, we only got those above 60. Now, these guys here, normally on these, most of these just pull up.
Oh, there. I'm going about 7 minutes. You going off the book?
You don't have to pull, you don't have to pull, you don't have to pull. Most of them have to be able to pull out. Well, let's regulate it.
Hey, what did the wrong actuator you mentioned?
Oh, yeah. God. That's the big point, right? I'll get back in sync too. Okay?
Yeah, you can.
No, you got number 5.
You got, and you, all right.
Yeah.
This is where I went up on.
This is just check.
How far away did you put that? What did y'all say? Yeah, number 5. That's what I'm looking at. You're 5. Yeah, so here, get down here. It's supposed to be around 5, right?
These things,
Yeah, I know.
these little triangles relate to like all these.
That's why you have to tear your rope out. Does anybody have an extra manifold? Yes and no, but you'll need it for the last second lap. Or so too loud. I don't need to see it down here. Are you down here yet? No, you're not, because I see a blank page right there, and I don't see number 5. So when you get down here, you're through. Right? You're supposed to operate. By the way, what's nice about these, you can't really hurt anything, right? You understand that? So you're supposed to check these circuits out and see if they're working.
I'm ready. Me too. Oh yeah.
Yeah, go all the way to the beach.
Man, what? Hey, right. Crazy.
Don't y'all love first day in lab?
Mm-hmm.
It can go out. That's extra.
When you push the button, it swings, and when you let go of the button, you retract.
There's gotta be one around here somewhere.
It's written around.
Okay. Found one? Yeah, we got a really short one.
I'm missing a single cylinder.
Nobody's got an extra manifold?
I need a single acting cylinder.
We had one somewhere. I was carrying around in my house. Yeah, I had one somewhere. I was carrying around in my hand. Here you go.
I got it.
Here you go. Thank you.
You gotta go all the way to the thing.
Well, I'm gonna do that down here, but say how the thing works, right? So what you did is you draw the limit on the circuit, right? That's not gonna say what's gonna happen when I put that. Yeah, so basically how the circuit operates. Okay? You ready? I'm accepting. Did you get the next lap done?
Sure.
You got the next lap?
You turn on.
Okay, you know that's working, right? Okay, next slide, please. So this is the symbol of silence.
Okay, that's what I'm saying. So that'll be, but, and I think this out there.
Because I'm gonna take that off.
Right.
Oh, okay. Okay. I'm cutting you off pretty good.
Okay, so this is my job. Okay, so I didn't have a law, and then
That's right. So it's a reverse.
I need a 5-way with the selector on.
You need a what?
5 2-way.
Go around and look for it.
Alright. I just let you know so you won't pick up.
No, like I said, we have no, this has a detail in it too. So it's got the manual operated with the detail. So probably have a selector too. This looks got about everything in it. Nancy must be on the Birmingham campus today. Hold on a sec.
Yeah, it's the most picture mix. I don't know.
All right, the call.
I got them motives. This is real. Don't do it. I got one more.
That's what I have for
Did you go back blue?
What about PSI? Oh, okay. Yeah. You want to do that? Back right now. You waiting on me? You there waiting on me? Huh?
Yes.
Yeah, I just have to look. There's one right here. Huh? Oh. Looking for a spare motor, guys.
What was this thing called? Is that detail out? That really allows displacing air because
Oh, yeah. Yeah, I ain't doing Buy one for us?
I think I can tell you where the other motor is, though. It's in the other building, in the motor control class.
Motor control class?
If I'm not mistaken. That's how come on that.
We have one over, we have
Oh,
yeah, but that goes with that.
That's also.
All the stuff. Terminology.
No. Right.
Should be some on the left. Mr. Richard, need you check it out for me. Where you at? Hey. What's the deposition? Oh, yeah. You have it hooked up to manifold. According to my schematic, it don't have to be manifold. We need to rewrite your thing. Yes, turn your pressure off. Physical.
I'm ready to check out.
Okay, so we're supposed to do.
I knew we had a couple of fried, but
Those things are more for me to figure out what we need to go back over to be graded. We don't check, I don't really check. Always take that, stick that, go back and catch up on, we just keep them covered. Yes. Who's ready?
After your motor cook.
All of them. I look on those trainers I got.
Don't go on now. They want to fire one.
Yeah.
Not good, guys.
All right, Mr. Rich, when you get a chance, now I'm ready. I got it right now.
Get this one right.
Have pressure, speed up.
Yes, that's the same.
Okay, close the door. White man taking the seat out here. You want to break that down? Say you break it down. Say you break it? Yeah.
I have two.
Yeah, but you need to say left. So you're saying this is extended. So according to this, it says extended all the time. So we got two actuators, so what we need to do is say, when I have it in this position, this guy extended, this guy's off, or when I switch it to this guy retracts, and this guy turns on. Okay.
This is my last time about this.
Okay. When their slides on whether it's running and stuff, so we can't say that.
You want me to?
We can't say that. Can't say when their slides on, the motor's not running. Because.
I get what you're saying. It's running, but it's
Well, it's not running, it's not because the air is not on. If it was
it's
on,
because the switch is not on.
because you're saying the motor would never run.
Right.
Because the air supply is on.
I got you
So
now.
what we're saying, okay,
My word is
depending
wrong.
on the position
So
of
the
this,
switch, the motor is
depends
on.
on what's gonna happen. Either the motor's gonna run and this is gonna be retracted, so it looks like we're doing some problems. You got pressure on?
No, I don't have pressure on. It works right, but my wording is wrong.
Right, that's what I'm saying,
Yeah.
but this is, you're writing this up, and you can say when the
I
air
get it.
supply is on, the motor isn't running.
I got, you know what I mean, but I just wrote the wrong thing.
Right.
It's
But
not.
this is the stuff we're talking about. When you write this stuff up, you're telling somebody how it's gonna work.
Trust me.
Now, I know how it works.
Right.
If I didn't know it, I didn't, but what if I didn't know that?
I had you messed up.
Yeah, I go over and say, well, the air supply's on, the motor's running, something's wrong.
Yeah. I got you. Alright, is it alright if I just scratch this out? Because there's a lot of erasing I got to do and rewrite the whole thing.
Don't scratch it out. I hate scratching out. Is it in pen?
Yes.
Okay, then I want it raised. But you don't have to raise very much. I wouldn't say.
Listen,
I'm ready. Okay, so let's see, right. Okay. Actually, it'd actually, it's like, probably the valve. But that's not, this is, back of the tractor. Can you see what the difference After all, that's gonna start with, I don't think violation there before that. Well, I'm not doing that. Now, we can right up. You got it, oh, man.
You not allowed to go to work?
I don't know, you got to sit down. So you're my technician, right?
Yeah, actually, do have a work. I don't know how that means, but I have to choose, but $5 going.
There you go.
$5 going to the
So not always. There you go.
normally.
So you write that up, you got that written up? There you go. Not decompressing, we're not really extending or retracting. So one time it's gonna be, so right now it's water. But you never tell me when it's gonna be extended. So according to this, yeah, so it's not extending the part, it's extending depending on what position the food is, right? Yeah. So I can start it right there, and just start it right there, right? So what you gave me here, it looks like the thing's always extended until it does what? But that's not exactly true, it's not always extended. So now it's what?
That's like swing. Swing on the cylinder, it tracks. Back to the motor.
So you don't tell me what's required to
There.
yeah, well, and I can take that sucker and run it right there, and it would be extended all the time. You understand what I'm trying to say? So what you gotta do is tell me the opinion of, you gotta tell me the position of this guy depends on whether it's water. Or, well, something's always open. Yeah, that's what I'm trying to do. So what you're saying is this right here, we call it frac. Okay. Say, so but the thing's retracted.
Yeah.
Okay, but that's what I'm saying, this is what I'm looking for, I'm looking for you to tell me, I don't have a spots idea, how this thing operates. And you're gonna say, okay, and this guy right here, in this position, this is gonna be.
When the valve is in a closed position,
Yeah, and the motor is off. And then when you turn it, the cylinder's gonna retract, and the motor's gonna do what's going on. So all you're doing is tell me what you need in this position over here, what I wanna know is, okay, what's it gonna be in that, what's it gonna be in this situation? We can't say closed and open, because something's always gonna be closed for look. So what's closed and what's open? So for a fire might be closed, but you can't say open and closed, because it's gonna either be exhausted or it's gonna be this, right? So right now, this side is open, this side is closed. When I flip it right now, this side is open and that side is closed. So we're gonna say when it's to the left or to the right, right? I mean, I'm not saying that, I'm just trying to say, you're trying to explain it. And also, if I come over here and I say, and I see you, I don't have that, I know how it works, but I understand if I got that, I don't know how it works, and you come up here and you don't give me detailed information. So all you're gonna say is when this is to the water. Yeah, there you go. You need to start bringing the pencil in. Anybody else waiting on?
I'm waiting on you too, Mr. Rich.
Okay, you. Okay, what I did.
I didn't even know. I didn't know that. I didn't like, what's going on? That was turned on and was on the track.
No, what we're trying to do, we're actually starting this operation. So you're not describing the circuit, you're describing how the circuit operates. So that means I come over here and I look at this and you're telling me I'm not concerned with that, so I'm coming over and I say, okay, what in the world, how does this thing work? I don't know.
How does it work out there?
Well, not connected to the
That's how you do it.
another, how you connect to the switch to the, that tells you nothing.
That thing, learn it. That's what you got
Well, like, if you got here to the kid,
extended.
or retracted, this guy right here. So what you're doing is you're telling me that, what you need to do, write it down. So that's what we're saying, okay, when I come up here, what do I need to do? Well, we probably need to make sure the water, make sure the pressure's on, and after that, I'm good. Now, when I put it to the left position, what's it gonna do? When I put it to the right position, what's it gonna do? And then now that's the detail off, that's a good operation. Okay? So who else is ready?
I'm ready, Mr. Rich.
What do you call it again? I have one. Actually,
Just put them in the drawer right now, because, odds are all you need is one, but we don't really like that. I'm working on you to make that sound. Exactly.
It be extended, right?
What was the pressure?
60.
I think that's that.
Huh?
I think that's that.
It's 60 now.
Okay. Are you ready? That's all we're doing. Don't break the circuit down.
When I turn it on,
Huh?
this is it retracts, it extends.
Yeah.
When you turn it on, it retracts.
This is not what it's supposed to do. What this is, you're right here. And I'm coming over here and I'm saying, how this thing works. And I'm gonna come over here and I'm gonna read your scripture. You're not around, so you're not around. That's what these are. So this is the way it works. So you're not gonna be out here by that system all the time, every time somebody comes in. You're not saying, let me tell you how this works. You know how this is, it's like, this is the way it works, right? Make sense? This is what I read. Yeah.
Yeah, no, I've just been,
Now, we don't have a normal, this is not a normal open or a normal close. electrical. So a normal closed valve, in one position, everything's gonna be shut off. And I have to flip it because something happened. Okay, here though, something's happening all the time. So this port is open, this port is closed. When you switch it, and this port opens, and this port closes. So we can't say this is a normally open or a normally closed valve, because of the way it works, right?
I got it, sir.
Yeah. That's what, yeah, it will. One other more thing, so you didn't say what, so here you said, which is good, but you didn't tell me what's going on with this guy. Okay, understand, and this is what we're talking about, a detailed situation. Yeah, and so now I don't know, this is what we're trying to do. You're trying to give instructions to somebody to come over here and start flipping switches, and they know exactly what it says. Yeah, the way it should work, not what it should do. And that's what it says, it says how the circuit operates. So the 528 valve is gray, from the, yeah, without you being here. Yeah, so that means they can come up here and say, okay, now I know what to expect. So I know I got it this direction, this guy should be in okay? And that's what these instructions are all about, is giving instructions. And that's what you gotta realize, that you can sit there all day and say, this is how it's supposed to work, but you understand what I'm saying. What's really neat is here you have to see what your word is doing. In DC, you do calculations and you make measurements, but you don't see things moving. And that's what's not done other places. So what you did is you told me you got two actuators and you told them what's going on in the center. So if I come over and I turn that thing, turns on right there, I'll say, well, something's wrong, that's another one. What do you mean? Where's the thing that left night? What does it say about what's going on in the night? Turn the air supply on, so the steam position, turn the air supply off, to retract, and we're not controlling it with this right here. We're controlling it with this right here. So I'm not gonna say I'm gonna turn the air supply off or turn the air supply on. Well, no. What? Yeah, but you're not saying, but you didn't tell me what's going on with this guy here. This guy here has no off and on. Okay, so what do we do? So what's happening right now? Pressure drop. What's happening right now? You understand what I'm saying? Oh, yeah, so you don't have your circuit. It's wrong. Of course. So what's this right here? This is the manifold, right? Okay. You got your motor connected to the manifold. The manifold is down here. So this is the manifold. They represent the power supply from the system. But see, you do know how it's supposed to operate. So what's going to happen is when I put this in one position, what's going to happen? It's going to put pressure up here. This is not going to have any pressure. So one position, this guy's going to be extended, this guy here is going to be off. And then when I switch my valve position, this guy's going to retract, this guy's going to be what? So if I can put extending the motor is on or off. So you got yours hooked up directly to the deal. Now some way, so look, you got this going to the manifold. This is not right. Number one's supposed to go to the manifold, right? Number one goes to the manifold. So this is the manifold in here. Number one goes to the manifold. That means I should only have two pipes in here. Two pipes. Right? One going from here, and then one going from here to there. And then I'm through. So this is the output of the manifold.
That's not outfitted on that. I mean, the only thing I should have going from here, is going over here to one. Right. And then I'm through with this guy right here. Okay. So this motor should go here. Where does the motor connect to? Here's the motor right here. What does it connect to? It don't connect to the manifold. It connects to the wall. It connects to which one? Not the switch, the valve. This is the valve. That is the little one. Ready, Mr. Rick? Okay, show me something.
Now I'm ready to should be right.
And so when there's plus turned on the motor, there's pressure and like the label. The cylinder extends.
I don't have a professional yet.
That's wrong.
No, to the left and to the
No,
right.
no. When the air supply is turned on, the motor has pressure. Now what's gonna happen if your motor has pressure?
So isn't the pressure going to it now?
What would happen if it had, what would you think would happen?
It'd
if
turn.
Okay, so we know that's wrong.
Right.
And by the way, when you say it's turned on, well, I can turn it on like that. Right. Or I can turn it on like that. Right. So when we come up here, so basically we're saying what depends what happens is, of course, we gotta have pressure, but what depends what happens is the position of this next switch.
See, that's what it's at the bottom.
Yeah, but we say this. Okay, we say, okay, when the air supply is turned on, the motor has pressure. When the selector switch is in the left, the cylinder extends. When the switch is to the right, it retracts, and the motor turns.
So I just need to erase that line and then the rest is right.
Well, yes and no, because what condition are my two actuators on when it's in the left position?
Extend and over and
Okay.
still.
Okay, it says that. According to this motor's gonna run all the time.
That's why I say if I erase this line, when the S5 turn on, so let's switch to the left signal extend.
And the motor is,
Not moving.
Okay.
Well, not turning.
okay,
Alright,
and then when I put it to the right, the motor was what?
turning.
Right, understand?
Yeah.
So according to this write-up, it's going to come over
Oh,
all the time. So just little things, right? And this is what we're talking about. This is what I've been saying, is what this is I'm gonna come over here and you're gone, you're off ship. And I don't know how this thing works, and I'm gonna pick up this thing and say, well, I'm not expecting this thing to do.
Run.
When the air supply is on, the motor has pressure. Okay, I turned it on and the
It's
motor
better.
don't have pressure. So, and you can't say when it's on because it's on here and it's on here, right? Okay. So what we're gonna do is we're just gonna say, okay, once I got pressure, right, then when this is off to the left, this is gonna happen. When I switch to the right, this is gonna happen. Okay. That makes sense?
yes.
You got it all? You need to turn it on. You got it. Or how much pressure is it? This motor's gonna be a whole little bit. If you're not self with pressure. Yeah. Now, this is really good, but what you're doing is giving me the description of the circuit and not the operation. I want to see it. Yeah, but when you turn the switch on, it's control.
Then, it tells you what that is.
Yeah, but. Okay, so I come over here and I do this, and the switch is in that position right there. And I come over here and do this. And you're saying turn the switch on control. Now it's gonna do opposite of what you say. So we're not, when you say turn the switch, I can turn the switch to the left. Or I can turn the switch to the right. This thing he's gonna do. That's what you like to say, turn your car. Turn your car. Turn your car.
Let's see it,
Wait, turn your car. Which way you gonna turn? No, turn your car.
Okay, but the next person beside you could have said what? Okay, so that's what I'm saying, so we're not, when you say turn this thing, it's got two positions, so you gotta say what's gonna happen in the left position and what's gonna happen in the right position. So if I come over and put pressure up, so right now, you say turn the switch, okay, so here it is right here, look. You say turn the switch, I turn pressure on. You say turn the switch. You say this guy right here, this guy retracts, and that guy right there, and that guy goes off. Is that correct? You turn the switch. Okay. This is what you got, when you turn the switch to the left, this is gonna happen. When you turn it to the right, this is gonna happen, right? Because this switch has no longer. So, right now, this valve right here, this valve is open, and this is closed. Change position, this is open, this is closed, right? So this guy here has no off. There is no off. So the only switches that have an off is a normally open or a normally closed valve. These are not normally open or normally closed valve. So normally open or normally closed valve is only a 2 holes. If it's got more than 2, if it's not normally open or normally closed. We can have a normally open center or a normally closed center, but this is a 2 valve. There you go. Oh. It's also they would have to, on these, since 3 is always dissolved, we don't have to have a next folder. That's the question. Yeah, so if we take this cover off, it would be 2, 4, 3, and 5. Like we have no control. Yes, nobody else is doing it. Anytime you're almost there, all you got to do is get it. And that's what you got to understand. What y'all do is, I don't have any idea what's going on. You're going to Texas somewhere. And I'm coming in here and I'm going to say, well, I need to operate this thing.
Right.
So if I'm going
Yeah, I should be from town.
when you turn it on, yeah.
You are not alone.
No. You got it?
Yeah. I don't know, you guys tell me. Apparently I don't got it. I don't ever got it.
So tell me.
I'm talking about this.
Yeah, but this is what you can't understand. This guy here has no off and it has no on.
I know.
It's got a left position and it's got a right position.
I never said it was off or on.
Turn the air supply on, turn the switch, motor set. Turn the switch. Okay. So
I said the motor was off.
okay, but we got 2 actuators. What position do I have it in?
The left.
Okay, so what position of the actuator is in the left position? This guy's what?
Okay.
This guy is
Okay.
extended.
Extended.
This guy is off. Okay. I turn it to the right position. This guy retracted. This guy is off. There you go.
That's what I put.
No, you don't. Turn the air supply on, motor turn. Turn the switch, motor stop. Well, okay. So you're telling me that, and I come over here and do this, right? And you come over here and say that. Right? Understand. So what you need to do is tell me what happens here. We got 2 actuators, and they perform different. And we don't have an off and an on. When you say turn it, I could turn it this way just as well as I turn it that way, right? You understand? Yes or no? Yeah. Okay. But you don't tell me that here. So you just told me how it operated. You said, okay, I turn the pressure on. If the switch is in the left, what happens? This guy. Okay. All right. So that would be when the valve is in the left position, the cylinder extends and the motor's off, right? Then I come over and say what? I turn it on the right. That's what I'm saying. So what you got to understand is, this is what I was telling everybody. you're leaving for the day, and I come over here and I see that, I have no idea how this thing's supposed to work, right? And now, but you explain it to me, it's just like you did write it up. No. Oh, this might have.
All right, I think I got it now. I'm gonna check this case, but you gonna check it out, Mr. Richard, wait till Monday. This is my last time, not then I'll get it checked out.
This is the inventory right
All right, Mr. Bishop, where we
here.
put the one?
This is new, so this is what we'll do, Monday. So this is the inventory right here. And what's nice is not only do they have what's supposed to be in there, they got pictures.
Oh, what each one is?
Yeah.
Oh, we can use that book then on test.
Well, I'm not gonna ask you what does the silver look like. It's got all the ratings on here about the thing. Yeah, and ours, so we can run this thing all the way up to 8 bars.
You gotta just turn it into it.
But you're not through with it.
Yeah, okay.
Then I need to see it operate. Well, I need to operate it. Okay. And you put them, go to the left, go to the right, and you put it to the, so yeah. You still don't have it. Okay, so I got 2 actuators. This stuff is running 2 actuators. What you're telling me, you're telling me what's happening with. Yeah, but you're saying the motor's running, but you never tell me what's gonna happen when I got it in the other position. So here we go. The control is to the left and the cylinder is steam. Okay, so that's to the left. Is that true?
To the left. And the motor is out.
Okay. So that's what, so here's what you said. You said, turn the switch to control to the left and the cylinder is steam. Turn the switch to the control to the right and the motor will run. It will hit. First of all, you need to get really away from using it. Because what is it here? What's it here? Everything. So you said it, so what do you need to put that? It will be tracked. Now, of course, I know what you're talking about, but you're talking about the boss that has no idea, right? And you say the motor, while the motor, while the motor is running. So from that, it means the motor's running all the time. While the motor is running. Yeah, I know what you meant, but what you gotta understand, this is technical writing. Technical writing, you gotta be detailed. We used to have a class that was required by everybody called technical writing. It was a class that everybody in the career tech program had, which is great. Because what you're trying to do is you're trying to say, you say while the motor is running, it's not while the motor is running. So that would mean right now the motor would be running because you said while, right? So what do we do? Turn it to the left, right? And what's going to happen? The cylinder extends, that's correct. And the motor is off. Okay. Turn the switch control to the right, and the motor, the cylinder extends, cylinder retracts, and the motor runs, so the motor turns off. Not while the motor is running.
But I reword that.
That's okay. You okay?
Yeah. All right, I reword it.
Oh, you just said you were going to go over. No, we're here. We're on.
Right, have a good weekend.
So we got it on? There is no, not good. Turn switch to the left, motor extended, turn switch to the right. Okay, we still have the problem. So turn the switch to the left, the cylinder extends, and the motor don't run. Yeah. And
Load it up, you know, you do it. Yeah, I just put it on, load it up, that's gonna be part of it. So, you should be like, you're not leaving with your air supply.
I'm not leaving, I'm waiting on you.
Okay, you waiting on the sign?
Yeah, I've been.
Oh, you put your bag on.
Yeah, cause as soon as you say I can go, I'm turning
So where we at?
it.
Just-
My word is should be right now. Yeah, that's great.
Okay. So here's the power zone, and this is the left hand motor, isn't it? This is the right hand side. Okay. So this is to the right, yes. You gotta get used to technical reports, we almost never use that word.
Okay.
Cause how many gets do I have up there? So what do you need to put right here?
The cylinder.
Right? Yeah, in technical reports, you'll probably almost never see the word it. Especially when you got so many different things. If you got one thing, it works okay. But if you got 5 things up there,
You don't know what it is.
you don't know what it is.
Gotcha.
Okay, let's hit it.
All right.
Okay, now let's do.
Good. Do we have to break it off again?
Yes. Well, no, you break them. Right. That's one thing good about this class. We're not getting
Sure.
everything tore down to share.
You want to push the door up when I come out?
Yes, please.
All right, Mr.
Anybody else in here?
Okay.
Okay.
I don't know if the other guy.
Put your clothes, yeah, for me.
I see Monday.
All right.